Okay, so welcome back, and today we're going to talk about coterminal angles and reference angles. Okay, so where do we start? Well, let's start with coterminal angles. Okay, a coterminal angle is, or angles, I should say, are angles that have the same terminal side. Okay, so any two angles that have the same terminal side. And so let's use an example here. If I have an angle, right? Let's say we have our initial side, and I have another side here, right? And so we have our standard angle, and we have theta. Then any other angle that has the same terminal side, that will also represent the same angle, and therefore we call those coterminal. They end at the same place, coterminal, right? And so if I have this, well, basically I can go any multiple of one rotation, right? So I can take any multiple of 360 degrees, right? Or if I'm in radians, any multiple of 2 pi will bring me all the way fully back from here, right? So if I do theta plus n times 2 pi or plus n times 360 degrees, that's going to go ahead and give me all the way around, and that'll give me a coterminal angle. How else can I get a coterminal angle? I can subtract 360 degrees, right, from the angle. So I can do that. I can take 180 degrees, right? I can take this angle, add 180 degrees, and then take the opposite of it, right? Take the negative of it, which will flip the rate back over, right? So let's look at an example, okay? So let's say this is 120, okay? So that means if I add 360, then 480 degrees also represents that. Or what if I want to go this way? What if I want to go clockwise? Well, in that case, going clockwise is going to be what? It's going to be 360, right, minus 120, which is going to be what? 240 degrees, but it's going to be negative because I'm going clockwise. So negative 240 degrees also represents that, right? So all I had to do was subtract 120 from a whole circle, and that's the other side, right? Because I'm looking for the opposite angle here, okay? I can't say complementary, but the other angle that adds up to 360, right? Because I know this angle and this angle has to add up to 360, but again, I'm going the negative direction, okay? And then I can keep subtracting 360. So if I subtract another 360, well, that gives me 600. So negative 600 degrees also represents the same angle. And what else? Well, if I what else can I do? If I yeah, I think that pretty much sums it up. I mean, there's all kinds of things. So the thing is there's an infinite number of coterminal angles for any given angle, okay? Now, so that's coterminal, right? That's what we mean by coterminal angles. Now, there's also another type of angle that we call reference angles, okay? And so that's why I drew out these circles here to represent when we're in each quadrant because the reference angle depends on what quadrant we're in. So if we're in the first quadrant, so if we have a first quadrant angle, a second quadrant angle, a third quadrant angle, or a fourth quadrant angle. Now now this angle here is just because all of these angles are going to be the same, okay? Because this is also alpha, okay? From here. I guess I'll just write that. I'm doing this on purpose. Sorry, that's alpha, this is also alpha, right? Again, this is alpha. So I'm just showing, I'm dealing with the same angle in each instance, okay? Now, what is a reference angle? The definition of a reference angle is the smallest possible acute angle that is formed by the terminal side of an angle and the nearest horizontal axis. Okay? So, for example, theta is the angle of measurement. It's the central angle, right? In this case, we're in the first quadrant, so the central angle theta, the measurement of the angle, and the reference angle alpha are the same. Okay? So in this case, so alpha represents the reference angle, theta represents the angle measurement. Okay? And again, this is true for whether you're dealing with radians or degrees. So in this case, theta equals alpha. Let me write this. Okay. Here, theta is the blue angle, right? That's theta, right? So here's my second quadrant angle. Now the reference angle is alpha. Okay? Now, how do I represent alpha in this case? How do I get the reference angle? Well, in this case, my reference angle alpha is going to be what? It's going to be 180 degrees minus theta, or pi minus theta. Okay? Notice that this reference angle is the same as that reference angle. Now, what about the third quadrant? What if I have theta here and my reference angle, now my reference angle is this angle, okay? So how do I get that angle? Well, I need to find this angle. How do I get that? Well, in this case, it's going to be 180 degrees because I'm past the 180 degree mark. So it's going to be 180 degrees, or excuse me, let me, it's going to be my theta minus 180 degrees. Okay, since I'm past 180, I'm going to basically flip these two. So alpha, the reference angle, is now going to be theta minus 180 degrees, or theta minus pi. And then finally here, now I'm in the fourth quadrant, so now how do I get my reference angle? My reference angle is now here, so how do I represent alpha, my reference angle? It's going to be what? It's going to be 360 degrees minus theta. So it's going to be 360 degrees minus theta, or 2 pi minus theta. Okay, and so that's how I'm going to find the reference angle for each quadrant. And again, it should make sense the more you use this, because again, think about it. If I'm in the second quadrant and I want to find this reference angle, well, what's this? We know this is 180 degrees. So all I have to do is to find this is just, hey, if I know theta, then I'm just going to take 180 degrees and subtract theta from it. If it's in the third quadrant, well then, again, I know that this is 180 degrees, and so to get this angle, I'm going to now subtract theta, or excuse me, subtract 180 degrees from theta. And then likewise, if I'm in the fourth quadrant here, well, I know this whole thing is 2 pi or 360 degrees, and I've got theta, so if to get this angle here, I just subtract 360 minus theta. Okay, so again, if you think about it, you can derive these very easily. Okay, so you don't have to memorize them, but again, the more you use these, you're just going to automatically start remembering them. Okay, so again, practice. Okay, have a great day.